Hey, Intermediate Algebra, Miss Soli here with Unit 2, Lesson 2. We are still on systems of equations, but this time substitution. There are 3 total methods for systems, so we're going to go over each of the 3. This is 2.2, systems of equations, substitution. Eek. Okay, so we're going to do a similar thing where I'll give you an example, and then within that example, we will write out the steps. So for example, let's say I had this system. X equals y plus 8, and x plus y equals 10. So with substitution, step number 1, you want to solve one equation for one variable. One equation for one variable. That's already done in this one with my first equation, x is alone. We've solved one equation for x, for one variable. So that step is already done. Step number 2, substitute into the other equation. I'm going to write EQN for equation. So I'm going to take what x is equal to, and I'm going to replace or substitute or plug in to the other equation. So this here, I'm going to write x plus y equals 10. But instead of x, I'm going to write what x is equal to, y plus 8. The benefit here is there's only one variable that I'm solving for now. Y. Y is the only one. Solve. Okay, so let's solve this. Let's combine like terms, get y by itself. So like terms, y plus y is 2y plus 8 equals 10. Get y by itself, so let's subtract 8 both sides. Divide both sides by 2. Y equals 1. Great. Great. We're not done yet, though. So y equals 1, that's awesome. I still haven't found x. So to find x, step 4, plug solution back into equation. I typically like to do the equation that's already solved for x, so I don't have to do any like subtract from both sides, whatever. So this would be x equals y plus 8, but instead of y, I'm going to write what y is equal to, and 1 plus 8 is 9. So that's your solution. X is equal to 9 and y is equal to 1. I want to write my answer in a coordinate point because it's all related to graphing. Like think about if we were to graph these two, this is where the graphs would cross. So your solution is the 0.91. Okay. Another example. Let's do it. X plus y equals -4, and y equals -x plus 5. Okay, so again, this one, step 1 is done. There's already one equation is solved for one variable. Check. So what I'm going to do is I'm going to write out the top equation, but instead of y, I'm going to write what y is equal to, -x plus 5. Okay, combining like terms, x plus -x, that's 0. I'm left with 5 equals negative 4. Is that true? Does 5 equal negative 4? No. This means if I get an answer like this, like something that's not true, this is no solution. If I were to think about a graph right now, these two would be parallel. No solution. All right. Y equals negative 2x plus 5. And 2x plus y equals 5. Okay, so let's plug one into the other. Again, one is already solved. So I'm just going to write out this second equation, 2x plus, instead of y, I'm going to write negative 2x plus 5. Again, the same thing's going to happen. 2x plus negative 2x is nothing, is 0. So I'm left with 5 is equal to 5. Is that true? Yes. So this one is actually, these two are the same line. They're the same line. So if I were to graph them both, they would just be on top of each other. There's infinite solutions. So every single answer that you get, every single thing that you plug in for x will equal in both equations. All right, last example, we're going to do a little word problem. So let's say you're running a water sports center on a vacation spot. All right, and let's say the two activities that you offer are parasailing and surfing lessons. All right, and then let's say we need to find out the cost of parasailing and surfing lessons. So I have two clues. First of all, the cost of going parasailing and surfing is $130. The cost of going parasailing and surfing is $130, like it's a all together. And the other clue I have is there were 30 parasailers and 25 surfers. And the total I made at the end of the day was $3,650. Okay. And so I need to find out the cost of how much it is to parasail and how much it is to surf. Let's see. I'm going to write those together. So the cost of both is $130, and there were 30 parasailers and 25 surfers, made a total of $3,650. Okay, so let's use substitution to solve this because graphing would be pretty tricky on this one. That's a very high number. Okay, so step one, I need to solve one equation for one variable. I'm going to choose the top one because P and S already don't have a coefficient. They don't have a number multiplying by them. And it absolutely doesn't matter which one you choose though. So let's solve for P. So if I subtract S from both sides, P equals 130 minus S. Now let's plug that into the other equation. So I've got 30 instead of P. I'm going to write 130 minus S. Oh, 5s and S's look a lot alike. 5S equals 3650. Okay, let's simplify this. So I'm going to distribute the 30. So this is going to be 30 times 130 is 3,900 minus 30s plus 25s equals 3,650. Like terms here, I have negative 30 plus 25. So negative 5s equals 3650. Get s by itself, so let's subtract 3,900 from both sides. Oof, it's going to be tight. So negative 5s equals, where's my calculator? 3,650 minus 39 is, just calculating, 3650 minus 3900 is negative 250. Divide both sides by negative 5. So the cost of surfing is $50. Cost of surfing is $50. Now, I'm not done because I need to find the cost of parasailing. What I love about substitution is you've already worked to get parasailing by itself. So all I'm going to do is take this 50, plug it in here. 130 minus 50 is $80. Parasailing is $80. Now, when you're given a word problem, how I want my solution is like with a sentence or with words back. So your answer here, I'm going to write it super small. Your answer here would be the cost to surf is $50 and the cost to parasail is $80. Sentence. So then, I don't know, you kind of beat the word problem with a word problem.